Good? All right.
Good.
So I might as well start then. Thanks. This is Understanding Bitcoin Source 13, 13th one.
Good.
So I might as well start then. Thanks. This is
I was posting it.
Understanding Bitcoin Source 13. Comment. So yeah, Understanding Bitcoin Source 13. Fees and coin selection. Thanks. So today I'm going to be talking about fees. Everyone, you probably have comment. So yeah, Understanding Bitcoin Source 13. Come up fees on the problem of fees. How much you should add to a transaction. So today I'm going to be talking about fees.
Wait, why is my own audio?
Probably have comment. So yeah, Understanding Bitcoin Source 13. Come up.
You hear yourself.
Yeah. I was like, wait a second. Because I had something open in the back window. Yeah, so you've probably come up on fees before. If you've made a Bitcoin transaction, you want to know how much you should add to a transaction to see if it can get confirmed within a reasonable amount of time. And I'll be going more into that on the next slide. But first, I wanted something captivating or interesting to lead in to fees. And that is with this. Yeah, the energy needed to solve a block is nearing the energy set off by Hiroshima.
Oh.
Which is a weird calculation to make, but I thought was kind of interesting. Here are the napkin math calculations I made. So Cambridge Bitcoin Electricity Consumption Index, if you look them up on Google, you'll see they have some stats on Bitcoin energy usage. And they estimate that the cumulative energy from 2020 to 2023 was around 372.8 terawatt hours. And again, some very quick math, very rough. That equates to blah, blah kilowatt hours and around 4.3 E plus 17 joules. And I found some random physics article online. The estimated Hiroshima gave off about 6.3 with E plus 13 joules, which is like pretty close to the amount of the average energy spent per block if you were to do a computation with the assumption that blocks come every 10 minutes.
So that's going to go up in the future?
Yeah, for sure it'll go up in the future. Because only more and more energy is being used towards Bitcoin as more countries, institutions, whatever, adopt mining and contribute to the network security. But I thought it was a very interesting stat, that we had a kind of a very bad thing, right, in Hiroshima that killed a lot of people, and now we have a similar amount of like energy in terms of the scale being used towards something we see as good, which is having a secure,
The better way to harness energy.
yeah,
Secure the
towards a
money
secure financial
for
system.
many innocent people.
Right, where there's no seniorage from any one government. So
But this is going to make people want to develop free energy faster, right?
It's incentivizing
Yeah.
more people to harness more energy.
Yeah. And to
Without
learn how to,
eliminating life, but providing something for
yeah, getting
life
it
to
from
flourish.
natural sources.
yeah, doing it.
Volcano that they're doing in El Salvador. Yeah.
Right, exactly. Right, it's funding the energy projects of different countries because it actually gets cheaper to build out like some energy infrastructure because you could actually mine at the spot that you're generating electricity, which is a nice thing to have. But all that was to lead into this other computation, which is the price to mine a block using the average price per kilowatt hour in South Florida. And again, this is all napkin math, very rough approximations. But assuming an Antminer S19 XP gives off blah blah 21.50 joules per terahash, and we have this 586.95 exahash per second, a daily average, and then I did some other computations. And again, this could still be wrong. It's an approximation. But I came to a rough number of 315,485 for like the cost of a block using Florida's energy prices, which is about 15 cents, which you can get from Fred or like this.
So that's the cost for one Bitcoin?
The Federal Reserve Research
Right.
something.
Yeah, and it's for a block to like, or not. No, it wasn't a block. It was Oh yeah, a block with Florida's energy prices. Florida, as usually, would never ever pay 15 cents to mine something. And again, this is like rough. This could be wrong.
Is the block equivalent to one Bitcoin?
Three and a quarter
N-
now.
yeah, you get
Subsidy.
you get yeah, exactly. I think it's 3.25. Is that what it is?
3.1.
Oh, okay. It's
Or wait, three.
no, the
and
point
eight.
25 was halved as well, right? Well, the last one was 6.25, so yeah, it's
Yeah, it's one,
half of
1.25,
the.
which is
Yeah, yeah,
eight,
125. Yeah,
three
okay.
and eight.
Yeah.
So therefore, it's coming out to about the price of Bitcoin.
Oh, well, not this. This is a very expensive rate to be competitive. Usually, miners will move to Texas and get cheap energy there. This is residential energy costs, so you never want to use it residential for mining. They would kind of cut you off anyway for the energy consumption if you actually try to seriously mine.
That's good.
Yeah, and then the price of admission for a one input to output SegWit transaction, question mark, and it's about 85 cents, which is pretty cheap. If this is by mempool.spaces fee estimation for high priority, give it about 85 cents, and you can go on mempool.space and see the different calculations. And fee rates, which is what I'm going to talk about today, and fees are a question of what you, as Bitcoiners, are willing to pay for this kind of security.
Right.
And going back, 85 cents is a pretty cheap price to pay for all of this. So that's pretty cool.
Seems like a lot of value.
Yeah, for a lot of security. Yeah. So today we'll be going over a couple things. So what fees and fee rates are and why we have them, how a fee rate is calculated for a transaction, how Bitcoin nodes determine acceptable fee rates for mempool eligibility. I actually don't think I included that in this presentation, but I planned to. How the selection of UTXOs play into fee calculations, the challenges that come with developing an efficient coin selection scheme, and what the leading algorithms used for coin control today are. So hopefully I'll give a good primer on all these things. So what is a transaction fee? Can anyone give a?
Well, yesterday I had to move from wallet to another one, and it said high, medium, or low, and I put medium, and it only took like a minute, it was really fast.
Yeah.
And it was only like $1.
Oh yeah, not bad. So yeah, can you maybe give a definition of like what you think a transaction fee is?
That's how much the miners cost to charge to move your money, I'm not sure.
Yeah, they're pretty close. It's a fee that you pay to get included in a block. Yeah, to
price of-
incentivize the inclusion of your transaction in a block.
So it's the carrot, it's the bait to get included into a block.
Right.
But it was faster than the last time I had done something like that. Why, did something change or something?
Did you
Uh,
check to see the network, like what was going on like mempool.space and see?
No.
Okay, so
Yeah.
it was probably very different because at any given time there's a different environment.
Yeah.
Okay, so you can check as your blocks are going.
You can
forward.
see like, oh, where the last few blocks, how much bait did I need to put on here when I broadcast?
Yeah, what the fee was.
Yeah,
But if yours got in pretty quick, that's
Well, they
probably
estimated
just
$20
lucky.
or
Yeah,
maybe
if
the
it got
estimator
confirmed
was
quick,
overshooting it.
huh?
Maybe the estimator was paying too much.
Well, I mean, I said a couple minutes, so like,
Right.
it also depends on how fast a miner is able to produce these blocks. So I think it was also a matter of luck.
If I think I was lucky maybe.
Yeah, that it got mined a couple minutes after you broadcasted your transaction.
Because other times I've done this, I've been, wow. If I had chosen slow, how long would it take?
Who can say? It depends on which wallet you're using and what they're using for fee estimation. Sometimes it could take like a while. Sometimes it's a short period of time.
And what's the website where you can watch it?
Mempool.space.
That's space.
Yeah, mempool.space. It's a pretty. Yeah. Yeah. Let's go.
You got a chair over there, a couple over here, I'm here.
There's a chair here.
Cool. Alright, Adam.
Yeah.
Beverages if you get thirsty.
Yeah, some beverages in the corner here. So yeah, I was just going over what a transaction fee is, but I think maybe I'll just skip to the definition I have here. So what's a transaction fee in Bitcoin? Transaction fee is the difference between your input values and your output values in a transaction. So whenever you make a Bitcoin transaction, you're spending some old outputs that someone spent to your address. And all of the amount from your inputs or from your UTXOs that you have not spent in output gets paid towards the miner. It is an implicit fee, so you don't actually spend an output towards a miner. They get to collect that fee within their Coinbase transaction. So yeah, it is spendable by the miner who mines the transaction. Your transaction is contained within. Very simple explanation of these fees. 1 second, gonna switch. Perfect. And why do we have fees? Anyone want to take a quick stab at why we have
Subsidy's
fees?
gonna run out.
Okay.
So fees are how we incentivize people to secure the network.
Yeah.
And with a future state of lower subsidy, we need the fees.
Right.
What subsidy?
So it started with 50 Bitcoin for every block to the whatever miner mined the block, you got 50, and then half
Yeah.
for
So that
to
was
25
the paper or whatever that
to
was.
12 and a half to 6 and a
Yeah,
quarter.
this idea of a block
It just
reward.
happened.
For the distribution of Bitcoin, every single time you mine a block, you would get like a distribution that way. So in the beginning, let's say there was no Bitcoin, right? The Genesis block, there's no spending from that. So the only way to generate new Bitcoin was to kind of mine practically empty block with just this thing called a Coinbase transaction, which allows you to initially distribute Bitcoin to yourself. So first it was like 50, and then if you mine another block, you get another 50, and so on and so forth. And eventually when other people start transacting on the network, it's not just you giving yourself some from the initial supply, now you're also processing other transfers from people, you're collecting the fees for that.
Right.
Although in the beginning of Bitcoin, no one charged fees because mining wasn't a lot of energy. Well, there wasn't a lot of energy needed. It wasn't a competitive market. But yeah, fees is a good answer. It is used to incentivize miners once the block reward disappears, because every 4 years it's halving, and soon there will be no more Bitcoin that's distributed from the initial amount that was allocated.
Is somebody who has a node have to be a minor?
No.
So does it also incentivize node holders?
No. Yeah. There's no.
There's no profit for having a node?
Yeah, there's no yield, I guess, for having a node. Only thing is you, as someone who has like money in Bitcoin, can have software that verifies that the blockchain is truth, essentially. That you get to look at the open source code, you get to build it yourself if you really wanted to. You get to get like the hash of the binary and compare it with the distributable that you might download off the web, and so on and so forth. But yeah, and I have this other reason, which is still up the same alley, but he's right. You need fees to incentivize miners. But I had maximum block size, that we have a maximum block size of roughly 4 megabytes. So putting into perspective, we can get roughly 12,195 SegWit transactions per block. And the main reason is we have scarcity in Bitcoin with this block size, which is, I guess, why fees get competitive, right? Because you have a limited amount of space, and if there's multiple people trying to put the transaction in a block, then we're always trying to outbid each other. And if there was no demand for making a transaction, then there would be no really demand for fees. So
right now, are fees, when miners are mining blocks, they already have transactions on them. Is that accurate to say, or no? No.
Yeah, like they assemble a block full of transactions and then they start mining, because part of the thing that they're mining, the block header, has a commitment to all the transactions, because you make a Merkle tree with it, and you take the Merkle root, which commits to all of it, and then you start mining.
Okay. So right now, do fees not come into play until after all of Bitcoin has been mined, or are fees happening in tandem?
Fees are happening in tandem, so people are still paying fees. The miners still get a considerable amount in fees,
Okay.
but they get most of their money from this block reward.
Okay.
Yeah, or as a subsidy. And yeah, the reason for scarcity in terms of block sizes or space if you want to run a node and be a sovereign individual, verify all the transactions are correct on the chain that you're using, you don't want the blockchain to grow huge, because then it would take a long time to download and verify every block full of transactions. Bandwidth, it's, that is, again, along the same lines as space. And space, you could prune a node. For example, I have a prune node, so you actually don't need to keep the whole blockchain on your hard drive. I have about 10 gigs allocated. There's something like a prune argument you can put in your Bitcoin configuration to allow this. But so space isn't like the biggest issue, but there always needs to be people who have the full blockchain for new people who are onboarding onto Bitcoin, who need to get all the new transactions to replay them all. Bandwidth is definitely a huge problem, again, for blocks. Yeah, let's go on. And block propagation time. If you have really, really big blocks, it's going to take a long time to transmit those blocks to other miners across the world, for example. So yeah, it disincentivizes miners, because SHA-256, it depends on the amount of data. It processes data in blocks when it hashes things. So you typically don't want everything to be super huge, because then by the time the other person gets it on the other side of the world, let's say another competitive miner, they'd be at a disadvantage because you've already started your hashing process. Yeah, can one transaction A get prioritized over another transaction B with higher fee? So does anyone know the answer? Yeah. So does anyone know why this can happen?
Minor greed?
Yeah, well, it's saying, maybe I didn't state this correctly, but can a transaction A with a fee of like 1 sat get picked by a miner instead of a transaction B with a 2 sat fee?
Yes.
For example. Yeah, huh?
So
Yeah, but it wouldn't be the greedy path. Huh? Well, not quite luck either. It's there's other factors that play into it than just like a fee, which is this concept of size. So yes, because the transaction is not chosen by miners and nodes based off their absolute fee amount, they're chosen using something called a fee rate, which is why those who've played around with inscriptions, if you use a higher quality image and you put it in the witness, it makes the whole transaction bigger, and you have to pay more money for it, right?
pay for those pixels.
Yeah. And I see something in the chat. I know I haven't been responding, but Prem, transaction fee is a sacrifice. Why is my Twitch bugging out like this? To the transaction processing gods. We used to call them Visa and MasterCard, and now they are Luxor and Marathon. Great. We have fees because they're selfish gods who demand sacrifice. Great, yeah. No, I love it. It's great.
That's the real reason.
But yeah, so it's depending on fee rate. So if you give a good fee for the size of a transaction, then it'll get prioritized over another transaction. So if I have a very small transaction with a very small fee, then it might take mine over your very large transaction with a very small fee.
So fee rate is a combination of the fee and the size.
Exactly, yeah. And maybe I could bring up mempool.space so you guys could take a look at certain things. So this is mempool.space. It has no priority, low priority, medium, and high. It's about 86 cents now, 76 for low priority, with 8 sats per vbyte. So it uses something called vbyte, which is like bytes, but not quite. After SegWit, there was something called a witness discount, which means the estimation of sizes don't go by real sizes. You actually count the witness or the part with the signature as using less data to incentivize people to switch to the system, and for other reasons related to minimizing the amount of like UTXOs. So it's cheaper to consolidate UTXOs. Yeah, so this is as transactions come in, how they try and assemble a block with all these transactions. So this is pretty cool.
It's pretty cool, yeah.
Yeah, see, this is a pretty fat transaction. Fee $245, 361,000 sats.
It's like a work of art.
Yeah.
That is weird.
Yeah, it's a lot of art going on here. But yeah, sats per vbyte. Yeah, Prem also wanted to note mempool.space is 1. but not the only block explorer, which is true. There are other block explorers. Another one is Blockstream .info.
Yeah.
So this is another block explorer.
It matches your shirt.
Yeah. And there's other ones. And I don't like the blockchain.com one, but I know a lot of people used to use that.
Blockchain.com, they left. They're out of here.
Yeah, but the block explorer, I think,
The block
is still
explorer is
still
still
there.
there.
Yeah, so this is how you like look at the fees that are being, or probably a good rate that you could put on your transaction. So in any wallet, it allows you to configure fees with this metric. So 9 sats per byte, 8 sats, blah blah. So I'd always go on here because some wallets are really bad at fee estimation, and they will overcharge you by a lot of money. But is it?
Could you show a finished block, like where you can show one that's, like
Yeah.
the last block?
Like this one, 4 minutes, yeah. So yeah, this is the expected block, this is the actual block, which basically means mempool.space runs their own Bitcoin node, and there's logic in there to get a block template or assemble a block based off the algorithm that's used in Bitcoin Core. This is what they came up with, and this is what was actually mined. And sometimes there's differences for whatever reason. It could be out-of-band payments, or they're using their own custom algorithm to assemble blocks with, so on and so forth.
Yeah, I was staring at it, looking at like some blocks looked like took 10 days, some
Yeah.
took like 7 minutes, or some pieces of the block.
Right, yeah, different times.
Yeah.
It tries to average around 10 minutes, but sometimes,
Yeah,
like,
no, I mean like some of these little squares. It
yeah.
was like 17 minutes, and one of them might.
Oh,
have
after
been-
16, okay, got it, yeah. Yeah, another interesting thing about transactions is they don't expire. So if you broadcasted something to the mempool, and let's say it was dropped because the fee was too low, someone can save it if they have a large enough mempool and can rebroadcast it at a later date, even though you thought the transaction was lost. So if you ever make a transaction with like a really low fee and you think it's lost, it's always best to make a new transaction with a higher fee, spend that money elsewhere, so that someone else doesn't rebroadcast your transaction and catch you by surprise because they want to be a jokester.
Wait, say it again, so if you lose it because it's too low, you do another transaction with a higher fee,
Yeah, you could RBF it, what we call replace by fee.
and what will then do the other one?
It'll just make sure that one's no longer valid.
You
Because,
can't double spend.
yeah. So if it gets dropped by mempool, you don't have to do a RBF. You could just make another transaction because most mempools will probably have dropped the first one. So, yeah, I'll go back to here. So fee rates. They're pretty much going to say what I just did, but fee rates are the number of satoshis you pay per byte, or V byte, if we're being precise, of a transaction. Bitcoin Optech is a newsletter. They have this nice handy tool, and it shows you the sizes of your transaction given n inputs or n outputs and a transaction type. So this is something called pay to witness public key hash. With 1 input, 1 output, it's about 109.5 V bytes. Then it shows you the overhead, so the transaction metadata that you need, the amount that you need for the inputs, and the amount you need for the outputs.
So does this change? So like I guess what about a transaction? So basically this is saying number of inputs and outputs makes it more or less expensive. Is that right?
Yeah, well, yeah, the more inputs you have, it's another reference in the transaction you have to make to UTXO.
Okay.
So there's an overhead depending on how many inputs you have, and the number of outputs, there's an amount that you need to specify, and script pub key, which correlates to an address. So it needs that extra space, the more inputs and outputs you have.
Let's say I'm just sending like my Bitcoin from my Coinbase wallet to like my hardware wallet, for example, and I just specify amount. Is that like a standard like 1 input, 1 output kind of transaction? Or how does that get bigger or smaller?
Yeah, if you're doing it to Coinbase, then it depends like on your wallet, but and it depends on which UTXOs you have. So if you have like a whole bunch of small UTXOs, it's going to be forced to use them all, and you're going to have a lot of inputs. Exactly.
Okay. And it would still be 1 output is going.
Right. Yeah. you're also probably going to have change. It's very hard to get a precise amount with all the
Right.
small amounts that you've received.
Yeah.
So it's going to be 2 outputs typically, one to
Got it.
Coinbase and one back to yourself.
Another UTXO back to you.
I see.
Yeah.
Yeah.
But there are rare cases where if you're receiving even amounts, maybe you'd be able to spend an even amount and no change. But most of the time, people do have a change output. Yeah, and the thing with Coinbase, by the way, those transactions usually they pay a lot of people out when you're getting a withdrawal done.
Mhm.
A lot of other people ask for withdrawals and get queued with you, and they'll make a huge transaction, and one will go to you, and one will go to somebody else, and so on and so forth.
So is it cheaper?
Yeah, because it's almost like the overhead of a transaction. You don't have to spend that multiple times.
Uh-huh.
And there's always going to be metadata that you need on a transaction, regardless of how many inputs and outputs. So if you could fit as many inputs and outputs on there, it's almost like you're sharing that overhead of like the transaction version and all those other things that are always going to be on a transaction.
Do you know if Coinbase passes that on, that cheapness on to the retail user, or do they?
I don't know. I don't think so. I haven't used Coinbase in a while, so.
So when you
Yeah.
have like an older address that you've used a lot, it might have a bunch of UTXOs, so every time you do a transaction, it'll be a higher fee.
Yeah. Well, yeah, for all the inputs that you're referencing.
Alright.
What's a UTXO?
It's a unspent transaction output. So when I make a transaction and I spend some Bitcoin to you, right now it's like allocated. It's almost like you own it because you have the keys to that, but it's unspent. It's from me. So it's like, Bitcoin you have that hasn't been spent, but it's like in a certain amount.
It's kind of the model for Bitcoin amounts of like chunks of Bitcoin is a UTXO model, where other things will use like an account model. Bitcoin uses UTXOs.
Yeah. So I was gonna go over this, which is like the fee estimation algorithm in Bitcoin Core, and I don't know why. I just think it's I find it kind of complex, but mostly when I look at the code. But I wanted to explain how it works. So when you go to Bitcoin Core and you want some estimates, how it gets that number. And this is kind of like the best I could do to visualize it. I might get some details wrong, and I definitely like omitted some small things. But Bitcoin Core, it makes these things called buckets. And you have like intervals of fee rates. So like maybe in Bitcoin Core, it's actually 5% increases for each of these buckets. Here I did 100% increase. So first 1 sat, then 2 sat, and then 4 sat. And then I take these buckets and I put them in these periods. So I'm gonna end up using these buckets to count certain transactions. But if I want my transaction like confirmed within or if I want to track transactions that are confirmed between 1 to 2 blocks, then I'll use this counter. If I want to track transactions that are confirmed within 1 to 4 blocks, from when they enter the mempool to when they're put in a block, then I'll use this counter, and 1 to 6, I'll use this. So it's cumulative,
So you're querying, like, is this like to query what
Yeah,
would be
fee would be the fee that you want to
Like,
use.
that's the estimate or something.
Yeah, exactly. Or like if you do like a send to address on Bitcoin Core with the command line, like they typically pick a fee for you, right? You're not putting in a manual fee. So this is how their fee estimation works.
Gotcha.
A lot of wallets also use Bitcoin Core's estimation because they do it through electors. So Blockstream Green, for example, they pretty much end up pulling that information from electors.
So when she used Medium, it was the 1 to 4 block period bucket.
Well, these aren't the
They
exact
already have
bucket.
their own
Yeah, these aren't the exact
something
buckets,
based on it.
but exactly, it'll get something like that.
Like in mempool, we saw this, like it had, or mempool space, like it had like this.
Right,
It
yeah.
just said 8, 9, 4, and then no priority.
Right. So yeah, exactly, something like that. Mempool, I don't think they give the exact number of blocks that they're estimating, but it's the same concept. Yeah.
Is there any way you can, before you actually decide to choose low, medium, or high, is there any way to know how long it's gonna take? Beforehand?
No. So yeah, not really. It's not deterministic in when like blocks come in. Like if we go back to the mempool.space example really quickly, something. I mean, we've been saying this for a little while, but if you look, this is pretty odd, right? Like Foundry 51 minutes, Brains 51 minutes, Luxor 52 minutes,
Yeah, that's 3 blocks.
57. Yeah, 57
Yeah,
minutes,
that's not
57
right.
minutes, 61 minutes. These are coming really fast.
fast.
So typically, what this means is, that, I mean, from my opinion / perspective, is that these miners are really they have upscaled with some new miners, and maybe the difficulty is too low for them. Because like, look at the frequency of these blocks: 67, 62 minutes. Yeah, exactly.
And then there's this 30-minute, is that a 30-minute gap there?
Yeah.
52 and 52.
And it kind of would make sense. So
So
yeah,
we're gonna see a difficulty bomb coming.
yeah, and although we don't like talking about like price, like I don't like talking about price very often, but when you do see an increase in price, sometimes it does incentivize certain like miners to go and spin up more ASICs because they know they can make more money, even if their marginal cost of electricity gets a little bit higher.
So would you think the fees are gonna go up once the difficulty happens, the difficulty change?
Adjustment. No, I think they'll adjust. Well, it's more. There's a lot of different factors.
Sure.
Yeah.
I'm just curious your guess, like,
Yeah.
I'm not holding you to it.
I don't think fees are going to go up. I mean, yeah, I won't make any predictions about the
Yeah.
price, but the price is a good amount, like for them right now, to seem to have incentivized this, crazy mining of blocks. Yeah, these are coming in
there's
pretty
like
fast.
An hour between one, that's wild.
80 minutes,
No,
yeah,
no, no.
yeah. Kind of goes to 120, yeah. But yeah, they're really pumping them out right now.
When you send something, is the miners that are gonna be transacting your transaction, are they local, are they close as possible, or is somebody in Africa doing it?
It could be anywhere in the world. So yeah, it could be somewhere in Africa, Australia, like, who knows.
There's no geographical benefit
Yeah,
to finding the
right.
And they do it like as pools. So
Yeah, exactly. So it's usually there's a mining pool and a pool operator, and then you have all these people who sometimes like their companies that have ASICs, and they mine, but they send all of their hash to an operator, so they don't want to have to deal with all the logistics of like, well, there's logistics are just one part of the problem. They don't want to wait until they mine a block. They want to get paid for the amount of hashing that they're doing. Yeah. So really, mining pool operators pay for a hash, and they get more consistent payments if a miner goes with an operator. But logistics are also a reason. There are some very big companies that probably could get consistent enough block reward, with the subsidies and fees, but they choose to go with the mining pool instead because of some other reasons, which, one of the speakers, David, spoke about at Bitcoin Day. So yeah, back to the estimation part. So Bitcoin Core, it kind of makes these periods of blocks. And again, it's tracking transactions as they enter the mempool and to when they actually get confirmed, like what you noted with the block and after blah, blah minutes. Except instead of after blah minutes, it's saying after one block, after two blocks that went by, the third one, got confirmed. And let's go to the next slide. Yeah, and I guess I have this a little weird, but this is an example. So Bitcoin Core actually uses something called transaction confirm stats, which is, it's like the class, if you're familiar with programming, that they define to do all this computation. And they initialize 3 of these transaction confirm stats, one for like short term, like granularity, one for medium term, one for long term. I don't really go into all that in my example. I just go into how one would look like. You could choose whether it's small, medium, whatever term. I picked my own custom configuration parameters to make it as simple as possible. But I just thought it was interesting to look at. So yeah, you start off with these periods, and then you get a block that comes in. And let's say this block's fee rate was 1 sat per vbyte. And you want to get it into like the mempool, so unconfirmed transaction. And that's fine, then it goes into an unconfirmed transaction. Once it's finally confirmed, let's say after 2 blocks of waiting, so we get in that second block, and we will be put into these counters. So again, this counter is, if it's like 1 sat per vbyte, pretty much, it'll get added to that specific counter. But it gets added, actually, I think I might have done this wrong. Well, it should get added to all three, but it shouldn't get added to all these fee rates. It should be 1, 1, 1. I did my visualization before I did the example, so there are some things that are off. But yeah, so this is 1 sat per VByte, so it actually shouldn't go in all these, but it should go in every single period, but it shouldn't go in every single fee rate bucket because
Can you
it
give
really
the
aligns with
example
1.
again? I'm sorry.
Yeah, because I kind of like messed up here,
Yeah,
it's
I
like
got you.
harder.
I'm gonna do more listening and visual side.
Yeah.
Yeah, don't use the arrows, just
Yeah.
pretend there's the transaction there.
Yeah. So you could. This is just for reference. These are the periods that like Bitcoin Core might keep track of.
Right.
They have like the fee rate counter here, and if this transaction got in after 2 blocks of waiting, so
Okay.
that means you'd add it to each of these because these are all cumulative. Did it get within 2 blocks? Did it get within 4 blocks? Did it get within 6 blocks? But you want to add it to the counter that corresponds with like the fee rate that it's like it is in, or is it all of them? I forget. Of 1 sat, 2. I think it should just go in here, or maybe it should go to all of them. I have to look at the code again.
Well, if it goes at the top, then it ends up in all of them, right?
No, it doesn't go on the top. This is just for reference. Yeah, these arrows maybe aren't the best, but I'm adding transaction B. Here it seems like I did add it. Okay, maybe it is cumulative because fee rate counter. You know, I feel bad because I have to look at the code again. But this is a good example. This is a little bit easier to do. This transaction has 5 sats per VByte. Transaction B gets unconfirmed, and then we add it to the correct periods. So because this is 5 sats per VByte, it's not going to go into the 1 sat per VByte, and it's not going to go into the 2 sats per VByte, but it will go into the 4 sats per VByte. So let's say like we'll go and add it in here and here, and it doesn't go into here because it took 3 blocks, not 1 to 2. Yeah, did you have a question?
Well, since it's 5 sats per VByte, wouldn't it be a higher priority than the 1 sat per VByte?
Well, it's not really thinking in priority as much. It's easier to think about like, did this get confirmed within 4 blocks? Did this get confirmed within 6 blocks? And if it did, then add it to the correct fee counter of this period.
Okay, what do those fee counters do? They do something to the.
This is for incrementally adjusting the fee that you
The
broadcast.
difficulty.
Yeah.
Oh, okay.
Yeah, well,
yeah.
yeah.
I see, gotcha.
So this is how Bitcoin Core is figuring out when you are like saying spend what to broadcast. right?
Yeah,
and
yeah.
I get it now, so it's for future prediction, it's not.
Right, for future prediction, yeah.
Okay.
We haven't done the final calculation yet, by the way. This is just the metrics they keep track of.
Sorry, continue with that thought though, like, cause I didn't fully get it. So what is the point of keeping, so we're keeping track of the period and the fee rate, in order to adjust the difficulty at some point?
No, in order to predict the fee that a transaction would need to get within, let's say, 2 blocks, or within 4 blocks, or within 6 blocks.
So this is like the self-adjusting, like retroactive adjustments.
So yeah, it's
Right.
using this information.
Yeah.
Yeah.
For that place where you predict what fee you're gonna do. This
Yeah.
is past.
And the prediction is good for a person who's about to transact on the blockchain?
Yeah,
Okay, so it's like thinking about the user who wants to know what they're gonna pay.
exactly.
Okay.
Yeah. So if you're wondering how they estimate it, and like knowing how they estimate it actually allows developers to make better algorithms because these calculations don't work well in high fee environments, which we've seen, which results into people like overpaying for blocks or to get transactions in their block. And mempool.space uses a different algorithm. They do not use this, and theirs is actually typically a lot better than Bitcoin Core's. So, yeah. So you'll use a lot less. Another one that doesn't use a Bitcoin Core fee algorithm or like some derivative of it is Blue Wallet. They also have their own spin on things, and you will also pay cheaper fees on Blue during high fee environments because of a differing fee algorithm.
High fee environment.
Usually it's when some event happens, you know.
Make it the market crashes,
Um,
or the Bitcoin market crashes.
Yeah, maybe there's going to be a lot of trading going on chain. Typically, they happen with exchanges, though, so maybe not. On-chain events maybe are a better example. So inscriptions and ordinals and stuff like that, those cause a lot of congestion.
Some crazy fees for the next like 100 blocks after that.
Yeah, because of Runes. Runes was launched in the halving, so we had a lot of congestion for that as well. Yeah, and this too. And actually, yeah, so again, I think to clarify, this example, only this first one should have been added. But I could confirm, but I'll have to look at some code if you guys are.
I get the big picture now that
Yeah.
I did before.
Let's see if I could bring this over. I don't know if this window is not wanting to come. But I think it would be cool to look at a code example if you've never seen Bitcoin Core code, but oh my goodness. Let's exit out of this. There we go. Sure. So, you know, this is more in depth than I've been going recently, but is it fees? I think it's fees. Oh, let's just look up Control F, transaction, confirm, stats. And this, yeah, fees.cpp and policy. So the thing that I was looking at where you record transactions is in, as you can imagine, a method called record. I don't know, it's slowing down my computer right now. It's a streaming. Yeah, so this is that thing that I was trying to tell you about. You have this thing called periods to confirm, and then you go through all of these periods to confirm, and then within each of these periods, so I is incrementing through periods, for a specific bucket index, you're adding 1 to it, which is what this plus is. Again, so it's only to one of the indexes of the period. It's not to all of them, because this is one for loop and not 2. I'm sorry this isn't like the clearest, but maybe interesting to see a parallel, even if you can't read it, that like this is what I was explaining.
What do the notes say? I saw Antoine had a note.
Oh, these are like their commits. Like if they changed it, this is.
This is C++.
Yeah. So this is the Bitcoin core code. Last person who touched, this line, for example, is Antoine 4 years ago, and this is his commit message. This is by Alex Morkos. Yeah. Yeah, another Alex Morkos. And look, a lot of this code has withstood the test of time. 7 years ago, 7 years ago, 4 years ago, when Antoine came to, I don't know, make whatever changes he made.
Well, maybe it didn't because mempool you said has a better way.
Right.
We're witnessing the
Yeah.
transition.
But I would say,
Seeing,
yeah, a lot of wallets were using Bitcoin Core. There still are. Another thing is like Wasabi. Wasabi uses Explorer for fee rates. Explorer gets it from Electors, which is connected to Bitcoin Core. And they had their own custom fee rate algorithm, but they very much did base their stuff off Bitcoin Core. So, yeah, anyway, this was just to confirm that I did the visualization wrong, which is what I thought. But yeah, so try not to think too much about this.
Oh, yeah,
So calculating the fee rate for a transaction, we want confirmed within 3 blocks of time. This should be 0, but if you did 0 plus 2, it would be 2 instead of 3. And then you'd ask let's just use 3, let's just say this is the correct state. If I wanted a block confirmed within 3 blocks of time, then I would take this value 3, and I'd ask if 3 is greater than our desired transaction count. So Bitcoin Core doesn't even try and estimate if you don't have enough transactions to reference, pretty much. You don't have to understand all the details, but let's say Bitcoin Core needs a certain amount of transactions before it's able to estimate any fee rate for a given confirmation time. And remember, these are all estimates, guess in the future.
So like if you sync
Yeah.
a new Bitcoin Core node, how long until it's gonna feel like, or is there like, when you say it needs a certain number of transactions,
Yeah.
like the first time you try to send off a freshly synced node is not gonna have
No.
a reference point estimate at all? And you're just gonna
No,
estimate
it has to go and process some of these transactions for. Well, no, if you're using, I mean, this is like maybe on a new chain,
Yeah.
but if you're using an existing chain, it will start processing blocks, and as soon as it gets enough transactions in those processed blocks, it'll start being able to estimate fees.
Okay.
Yeah, but really, you have to be up to the tip if you want to know. Like, you can't do fee estimation.
Unless you're really at the
Right, exactly. Unless you're at the tip, especially if you're trying to make a transaction into the next block or next 6 blocks, whatever. So yeah, this is more of the code, again, because I didn't want to explain too much of this. Prem said, seems like there's a good little crowd, no event afterwards. So it's good you're going deeper than usual. Yeah, I'll go into more code since,
I'm not seeing, is that on Twitch?
yeah.
Oh, okay.
So yeah, and then after get some specified threshold, it's like, is 3 greater than our desired transaction count, pretty much. And then if it is, you go into the next part. Was there enough successful transactions for our desired block confirmation time? And if there was enough successful transactions, then we go and like pretty much look at the fee rate of those relevant buckets. So we collect all transactions from fee bucket range, find which bucket the median is in, and return the average fee rate for all fee rates placed within the bucket. What this means is trying to find an easy way to explain, but I don't know if there is an easy this is the code. It looks at some reference transactions for your desired confirmation time. It looks for the successful ones out of those transactions. It gets like the bucket range that you found for the range of successful transactions by fee rate, and then it gets an average somehow from that range, if that makes sense. Again, the visualization might be better. So if it's like, I want it within these two, let's just say I count these up, I have some like threshold number, I have some other information about what's waiting in the mempool. I see, hey, is this like a high enough number? And I look at these fee rates and I'm like, yeah, let me get the average of this. Again, maybe not the easiest thing to present. But let's go to the next section anyway. Final calculation, this is the code. Again, I find it pretty confusing. The easiest way, yeah, it would be just for me to refactor.
Are these comments in the code, or do you have them?
Oh yeah, these are in the code.
Oh yeah, I see.
Yeah, Alex Marcos. He's the guy who designed this whole system. And what he said was this pretty simple fee estimation algorithm, which is like, right, exactly. I think it's a little bit like convoluted, especially the way he
Simple,
programmed it
generous.
Personally. Yeah.
Generous assessment.
But if you actually wanted to see he has his own write-up of how this works. And you can scan that QR code and you can see his gist of when he first designed this algorithm. And I left out this other concept called decay, which pretty much allows us to not remove things in those like fee rate buckets. You naturally decay them, which is this other weird idea. So it's, yeah, a little convoluted. And especially if you look at things like Blue Wallet's estimation algorithm or mempool.spaces, they're a lot simpler and they're a lot more effective, which is why I find this funny. But yeah, I imagine this took a lot of work to design. It worked well enough for a while and for regular fee environments. But coin selection, huh?
2014 is.
Right, exactly, yeah. Coin selection. So coin selection, or what we were talking about earlier, which is should you pick your UTXOs to pay somebody else with? Sometimes you have a whole bunch of small UTXOs or small amounts sent to you, and if you want to spend the small amounts that were sent to you, it's going to make your transaction more expensive. So, and especially if you have large amounts with those small amounts, there's some like logic that needs to go in to thinking, how can I make this as efficient as possible? Is there a way for me to have no change? That's typically one thing you look at. And is there a way for me to minimize the amount of inputs I need to reach this exact amount? So an optimization problem, as I said here. All Bitcoin outputs sent to the same pay to witness public key hash address cost the same amount like to spend, even though they represent different values. So let's say you have a whole bunch of UTXOs or a whole bunch of Bitcoin to spend. If they're all of a certain, like this certain address type, they're all like roughly the same cost to spend as a UTXO. So the input size is not going to change just because their Bitcoin value is different. Because you're using the same amount of data, especially for, and specifically this type, pay to witness public key hash. It's a static amount of data that you're going to need for that input, which is the signature. So it's like, imagine having gold pieces that always weigh the same regardless of size, but are of different values. When you give them to somebody, how can you minimize both the total weight and the amount needed to be broken off for the change? So again, you want to minimize the amount of change that you have. Ideally, you could just like pay somebody and not have another UTXO come out of it. especially if it's going to be lower because it's change. So maybe a fun little exercise. So which pay to witness public key hash UTXO values should I use if I want to pay someone 4 sats? So let's say these are all sat, typically you can't get this small because of the dust threshold. But let's say I had a 2 sat UTXO, a 2 sat UTXO, and a 6 sat UTXO. Which ones should I use as my inputs to pay somebody 4 sats?
The 2 twos?
Just the
Yeah,
six.
yeah, well, the 2 twos. Well, yeah, in here I have, if I actually,
Is it as
Get
simple
out
as
of-
it sounds?
yeah, if I get out of here. Well, so actually some calculations. Actually, no, it's a 6. Roz is right. Yeah, yeah. Because,
Less inputs.
yeah, well, yeah, because SegWit makes it cheaper to spend inputs, which is one of the reasons they chose SegWit to incentivize UTXO consolidation.
Starting to come
Yeah,
together.
for legacy transactions they were different, but with SegWit you get a discount on the signature, so it's actually cheaper to consolidate UTXOs now. 2 inputs, 1 outputs is 177.5. Well, so here's this is no fees, so it would actually be cheaper to do the 1 input, 2 output here because it's less in size. Yeah, kind of makes sense, or?
I think I have like some definitions confused. So the UTXO values.
Yeah. So like, imagine I have some UTXOs. One's like you sent
One's
me
2 and one's 2, and I want to send 4.
right, and one's 6. Yeah.
So you're sending the 6 and you're getting the change back.
You're
Is
gonna-
Yeah.
that what you're
Now,
saying?
after you're
Exactly.
gonna have sent four, a value of 4 sats, and you're gonna have 3 UTXOs of 2. 2, 2, 2.
Huh?
Right?
Well.
After you
2
send
sent
4.
and 1 coming back.
If you do the cheap one, which is using the 6 value.
Well, one input
send
to-
4 and it creates a new one of 2.
Right. Yeah. 1 input and 2 outputs. You get one output back to yourself.
Right, of 2. So
Yeah.
after you send the 4, you're gonna have 3 UTXOs of 2 sats.
Yeah. If you had all these, yes.
Yeah. That would be the most efficient way to move 4 sats if that's your given.
Yeah. If you wanted the cheapest way to spend
Yeah,
a sat, that would be yeah.
Okay.
But I mean, but there's other things to consider in terms
But
of
then
like
later you're gonna have
optimizing.
a bunch of small. You're gonna end up with more dust.
Right. Exactly. If you keep thinking, oh, I want to optimize the cheapest
Today,
spend.
yeah.
Yeah.
Later stage, and if we're in a future state where like we're gonna look back and be like, wow, I can't believe back in 2024 we were below 10 sats per V-byte,
Uh-huh.
getting in high priority, or it could go the other way. But like we could be a future where it's 100 sats. I don't know. You probably
Yeah.
see a future where it's much lower than it is today, or what do you think?
What's lower?
the like
Lower fees.
the typical
I say the fees are always going up.
in terms of sat value or dollar value?
Even the SAT value, I could see it getting more competitive as a market as we start denominating things in SATs. If
Yeah.
Prem also adds some comment, doesn't a change of 2 end up creating bloat because the person you paid has a UTXO for 4, you have 1 for 2. If you send the 2 and 2, you consolidate them into 1 input. So yeah, that's another consideration to make. Like I said, this is the cheaper spend. If I was just thinking about cheapness, it would be the like 1 input, 2 output. But if I wanted to reduce like my amount of remaining UTXOs, then I'd do the 2, 2.
So this would be something that developer making a wallet will think about, not the user.
Well, so there's manual coin control that some people like to do.
Sparrow allows you to do this.
Certainly does.
Yeah,
Sparrow.
Desktop well.
yeah.
Oh, really?
Yeah, no, I'm definitely looking at
For
Sparrow.
most wallets,
Uh-huh.
most users won't do that, they'll use a wallet. with-
Yeah, that does this for them. Yeah, but hopefully it does it correctly, or else you'd.
Yeah, if you're using one that does it for you incorrectly, you're gonna, as a user, pay for what, you could have.
Yeah.
You're gonna lose your runes.
Yeah.
Or, lose your.
Yeah, and Prem asked the numbers at the bottom that I had for comments here. Yeah, these are like the
Final answers.
yeah, the virtual size, because
Here's the numbers.
Prem said weight, and like weight is a concept we use towards the block, but when we're estimating like something, a virtual size, a V size, we call it like virtual size. The weight is only when we're looking at blocks. You don't want to get, I think, 4 million weight units, but for size, yeah, it's a virtual size. That was derived from some weight concept.
That's kind of confusing though, to have these competing ways to measure.
Well, it was only made because we wanted to do the SegWit discount.
To differentiate.
Yeah, to differentiate and still have things remain consistent with the legacy transactions, with how fees are calculated and all that. And but I actually wanted this answer to be 2-2, so maybe I should have used legacy. But does your answer change with a non-zero fee? So if it was 2-2, would it change with a fee, right? So like, and how would it change? So this 2-2 wouldn't be enough, right? Like it'd have a zero fee associated with it, because I'm trying to pay someone 4, and I'd have to use this third UTXO. So it makes sense to just use 1-6.
Right.
Yeah, sometimes there's no right answer. Like you just do the best you can. Your wallet algorithm picks the best things it can, and you hope for the best. So they have these. There's a problem in computer science called the knapsack problem, where you have a whole bunch of items. Let's say it's like bricks, and each brick has a different weight associated with it, and each brick also has a certain price that someone's willing to pay for it. And you want to figure out how to optimize the amount of bricks you could fit within a backpack. So it's like, how many bricks can you hold? Maybe it's 2 pounds. So how can you optimize your value with 2 pounds of bricks, having a whole bunch of different size bricks with different values, not associated with their size? So this thing's called the knapsack problem. And the knapsack problem was used to analyze coin selection algorithms on Bitcoin Core, because the problem's kind of similar, where you have like these inputs, and if you're using pay to witness public key hash, those inputs are the same. But if you use pay to witness script hash, where you put a custom script that you need to fulfill to spend something, then you actually can have different sizes associated with these transactions. So now you have different sizes with the transactions and different values, and you have, again, this optimization problem where you have a lot of variables that you need to contain. That gets very hard. And this guy kind of explained it. So he had 148 as the number of bytes for an input, and I said it's not quite true, because witness script hash or pay to taproot can have scripts that cost more money for an input, because the scripts are bigger. And then the coin selection, all this stuff. You don't have to read all this. It's just something I found on Medium when I looked up knapsack and Bitcoin.
Who's Daniel Dyroff?
He's the guy who wrote this. And I just thought this was a nice little thing he wrote. Coin selection can be thought of as a variant knapsack problem in the following way. The knapsack, or the backpack, in this context will be a transaction itself to be filled with UTXOs, which each carry with them a weight, which is their value in BTC, and cost, which is like the size. Unlike the standard problem, however, the knapsack will have both a minimum and maximum capacity. So that's another variant on the problem. So with the minimum capacity being the minimum required funds for the transaction to be valid. So the sum total of outputs plus the transaction fee, right? You have the minimum, you could think of like a dust, right, amount. The maximum capacity is chosen to be the minimum capacity plus the dust threshold, or the minimum capacity you need to spend to somebody else plus this dust. The idea being that it is better to overpay the miner rather than create dust with a change output. Sometimes like if a UTXO you're gonna get back is too small, then you might just like put it into a fee because you don't want it to exactly, or get used in another transaction whenever you try and spend, because it might cost like very close to the amount that it was to make.
Gotcha.
So I thought this was a nice blurb. I didn't read the whole article, just this part, just the knapsack. So someone who has actively been researching in this area of coin selection, which is Merch. He is actually, I was gonna say he's a BIP editor. Is he? I don't think he is. Is he? Because we had trivia.
Optech newsletter editor.
Okay, yeah.
But I don't think he was one of the 6, was he? He may have been one of the new 6.
I don't know. We can check.
I don't know.
I know Ruben Thompson, Alalua, and some other people. If you guys don't know, huh?
Consor?
Yes, Brian Bishop.
Brian Bishop.
I don't know who. If you guys don't know, a BIP is a Bitcoin improvement proposal. So it's like if you want to go and have an idea to improve Bitcoin, you go and make this document, and then you share it with everybody, and it gets put into this repo. And it kind of, even though the proposals, a lot of them were accepted, and once they're accepted, they become spec.
Merch and John Attack are the others.
Huh? Was it actually Merch?
Merch.
Okay, so Merch is a bit better now. Cool.
Cam Zure, Brian Bishop.
Yeah.
Ruben, Alwalu.
Those are the
John
times.
Zach.
Yeah.
Those are the
Okay.
names.
Yeah. So those people who police this repo that people kind of use as a spec. Anyway, Merch, he was doing his master's thesis on Bitcoin, and he made this algorithm called branch and bound. And he has this algorithm listed on Bitcoin Stack Exchange. I just thought it was kind of interesting how he went about, developing this algorithm and how it seems pretty, straightforward and effective because he did a lot of different studies on if this would benefit, different types of spends. If you have this, randomized UTXO set that belongs to you.
Sorry, so what is the algorithm doing, like, overall?
It's trying to find the best UTXOs to use in a transaction
Okay.
to try and like minimize the amount of change outputs.
From a specific wallet or from a?
Well, this is an algorithm that can be implemented in any wallet.
Okay.
I don't know if this is ever merged into Bitcoin Core. It might be, but a lot of other wallets have started to use things like branch and bound because they want to be more efficient with how they
What
handle
does
people's.
branch and bound mean?
Uh,
Like the way it moves to like go branching and then jump.
yeah, it's like a conceptualization of this algorithm. He has like a tree.
Go branch.
Yeah,
bound,
yeah.
bound.
Yeah, well, yeah, you're bounding your remaining options using this tree, and like you look through these different branches, and if you scan this QR code, you can see he has a diagram, and I didn't add it in, but he has this like
But it's
tree.
a sorting algorithm, right?
Not quite sorting. It's again, it's trying. It's like, I mean, almost everything could be like reduced to search. Like you're searching for an optimal set, right? Of UTXOs.
And the idea is that these are going to be UTXOs that you spend.
Yeah, and the idea is and
To reduce
long term exactly to reduce your fees. Yeah, how can you reduce fees? And one of the ways is figuring out how you have like less UTXOs that are dust like, or minimizing the change that you have, or not having it at all. Not like just minimizing, not having it all. So.
I'm posting all the QR codes for you because your face blocks them.
Okay.
It's true.
That's unfortunate.
Put 'em up on next time.
Yeah, let's see if I could change where I am here.
Yeah, you probably do that.
I'll put myself at the top right.
Yeah.
I don't think I have anything in the top right. Yeah, is there ever a need for manual coin selection? So again, we were going like, is this all for wallet developers? Can I do anything? And Sparrow was brought up.
So if you have a Sparrow wallet, you can choose.
Yeah, you could choose the like amounts of Bitcoin that you've received. So if I got like 5 from him, 2 from you, 1 from you, then I can say, and this transaction, I personally know I want to spend 3, so I'm going to choose this 2, this 1, but I need fees, so maybe I'll bring his in, and I could make
Have you ever used that?
Sparrow. Yeah, I personally haven't. I think.
Use it, actually like the Electrum, on desktop. I think that's like been around longer. Sparrow's like very good too though. But that's the thing, like there's different ways to compete and like do a wallet that either gives the user access to a better way to like transact, or somebody's like Blue Wallet has come up with their way to order and like find a better UX, spending less on transactions, stuff like that. So I think it's like one of the benefits of open source is that everybody can take Bitcoin Core and they can kind of bring what they see and extend it, and we all as users benefit from the options. But there's a double-edged sword where you have too many options, right? Like you have
Sparrow
that-
has a lot of options.
Yeah, you have that like
Yeah, too complex sometimes.
feature rich, or it's too feature rich. It's like advanced users only, or like you go to the grocery store and you have 10,000 cereals to choose from. It's just like the overload.
Tyranny of choice.
Yeah. So
Yeah.
Because like every time I meet somebody that's either interested in Bitcoin, they'll be like, "Oh, what do you think about X Wallet?" And it's something I've never heard of. But like, doesn't mean it's crap. It's just there's so many competing ways to do your Bitcoin wallet. And now there's a whole. I think it's good though. I think the competition means we have better options as users.
Yeah, it encourages innovation. And another wallet is Blockstream Green. You know, I talk about that one too, where you could green,
Green or green?
green, like GREEN, like the color. Yeah, it's made by the company that I work for, but they allow you to lock UTXOs, so it kind of gives you some control. And
There's a blue wallet and a green wallet.
yeah.
And
And
then
they have a hard
Yeah.
device that works with green.
Yeah.
It's called
Could you just
Jade.
do a paper wallet?
Yeah.
Could I though, like, just have a paper wallet,
Uh,
put it like a command line and just like write in my transaction and block
It would be, yeah, like,
It'd be hardcore, but could it be done? Like,
kind of. Not practically, I guess. Well, maybe with a calculator to do signatures.
okay.
Special, maybe. It depends what tools you have. But
Okay.
but yeah, you could keep a lot of information on paper and try and do all the math yourself, or have smaller programs that are offline to do the math.
Yes, yeah, it's
Is
not.
there anything
Yeah.
to get your keys if you didn't write them down?
Like some hardware wallets let you look at your keys again.
You have a phrase, a seed phrase?
Uh,
No, that's what I'm saying, the 12 letters.
yeah,
12 words.
yeah. It lets you look at.
12 letters of them?
No, because yesterday I had two wallets, and one of them I had the seed phrase, written the 12 letters words written down. The other one I didn't, and I was like, shit, where is this? So I moved it from that one to the other one. Because because there's no way this I know.
Yeah, sometimes in the settings they'll have
You
like
can-
show seed
yeah,
phrase.
You can reveal, there's certain wallets.
Yeah.
Green probably lets you reveal existing, right?
I think so. I've never had to,
I
but
actually have done that in
This
green.
is your hardware wallet, actually.
Hmm.
Not a,
Ledger.
okay. Ledger.
Well, green has Jade, which is the
Ledger.
signing
Put it-
device.
put it
Yeah.
for me. Yeah.
Which is, what does a Jade go for, like 40 bucks?
no, I think now it might be like 60.
Okay.
Yeah, we'll raise in price. Before it was 50. Yeah. Is there ever a need for manual? Oh, did you have? Okay. For manual coin selection. So I wanted to go into why you'd ever want to do manual coin selection. And you have privacy attacks. So if an attacker can identify your Bitcoin address, you know, let's say an old one, they can send you a tiny amount of Bitcoin to that old address. And does anyone know why this might be a privacy issue? Has to do with coin selection. If they send to an old address, and I can also explain, but
Maybe.
They're gonna try to reveal, like, what, like, I don't know, actually.
They-
Yeah.
I get a
Huh.
warning all the time if I
huh?
use the same
Yeah,
address.
yeah. Well, there's challenges, huh?
They could trace it and see you're
You
doing
spend
it.
Yes, yeah, exactly.
Yeah.
That's exactly it. Some wallets, like they'll look through your old addresses to see if you have Bitcoin because they want to report a proper balance. So let's say I emptied, like, and usually you want receives all to be new, but let's say I use a receive address and like I spend it, you know, directly all to River, and then I use a new receive address and then I spend that all directly to River. If someone were to send a small amount of Bitcoin to one of my old addresses, and I'm still using my new addresses, and I get a new payment, and I send it all to River, they'll say, hey, this address is actually associated with this other old address. Because my wallet might not like differentiate, like, hey, this is all from like to an old address, we're not gonna spend it, because like, why wouldn't you not wanna spend your own Bitcoin? So I'm gonna spend it, but now it's gonna like dox me with my new address. And you kind of ruin privacy that way. So like, yeah, if I wanted to clear out my old addresses and like I did do that successfully, someone can still tie my old address to a new address because my wallet is just saying, hey, we're going to use all the money he has because he said send all. So what you do to preserve your privacy, usually it's people sending small amounts. So you just lock that UTXO. And like you say, hey, don't like use this. If you use an advanced enough wallet. And if you care that much about privacy.
Wallet not to accept anything?
So old addresses, I don't think a lot of wallets have that functionality. That's like, or it's not that like, it's not that you don't accept anything. Like I could force it onto this old address, right? Like as long as you gave it to me. Like if you bought something, or if I bought something from you and I gave you some Bitcoin on an old address, and then like Roz also wanted to give a payment to you, but like your old address you cleared out to River, I'm gonna send something to the address that I used to give me. And now when you send all that money to River, I can say, hey, like this payment that she got from Roz is a big payment, but like I know it's still her, you know. And there's not really a way for you to tell like your wallet that you can't stop receiving Bitcoin on a certain address. It's always belongs to you. But what you can do is you could like blacklist the UTXO from being chosen from coin selection, so that if you did get like 100 Bitcoin payment and you're sending it to River, I don't know that it's you. Yeah. That makes sense.
Yeah, no, it makes sense.
Now you're blocking the first line of the presentation.
Okay, well it's fine. I explained it. Yeah, and then something some of you might be interested in, which is some maxis would hate, but I think it's interesting to explain, of course. Ordinals. So ordinal theory is a numbering scheme on top of Bitcoin. It allows you to assign a set of unique numbers for every UTXO. Really, it's like the numbers correspond to sats in the UTXO, but it's easier for me to think about it's a set of unique numbers that are on a UTXO. So when creating a new UTXO, the UTXO being spent will have the set of numbers associated with it transferred to the outputs. So if you have a UTXO or you have some Bitcoin that has some like ordinals in it, and you spend that Bitcoin or that UTXO, those ordinals get transferred to some of the outputs according to some rules. And to prevent a UTXO with a specific set of numbers associated with it, you want to tell your wallet not to include that UTXO within your coin selection algorithm. So when you're selecting coins, you don't want to like spend your, I don't know, 3 Bitcoin inscription. So that's where it would be useful to use something like Sparrow and try and limit which UTXOs can be spent if something is very valuable to you. And yeah, I think this was the last slide of presentation. Nothing else to talk about. It's like ordinal theory is like a scheme, and like
It's a theory, but it's not a thing.
yeah, it's called a theory. It's more like a
I
construction.
like meta protocol.
Yeah, it's a meta protocol. It's a protocol
Like the
that's built on
protocol
Bitcoin.
doesn't give a shit about it, but there's people who buy into ordinal theory as a meta protocol on how you can. I think scheme is a numbering scheme or a standard for ordering. Like accounting teams will use first in, first out, or like last in, first out, like different ways to kind of keep track of something. So this is a way to keep track of Bitcoin, basically sats.
It's NFTs on Bitcoin.
But it allows you,
Oh.
to associate the inscription, which is the NFT. So an
And
ordinal is
it's
Yeah.
like,
hard to sell.
what order?
Yeah. Yeah.
What order is the
I know
Bitcoin
it's
in?
not exactly.
Yeah, it's a way that
It's
people
not a
have.
token.
In order to
Yeah,
describe-
it's
Right.
making non-fungibility.
And
So-
that's
Uh,
why ordinal sounds like ordinal.
Yeah.
Bitcoin is still
So ordinal theory
non-fungible.
gave us
The-
inscriptions,
but
and
if
it
you
also
put a
gave us
certain
more
like
recently at the halving
goggle
rounds.
on, then it now becomes.
No, Bitcoin, you wanna say it's fungible. So put the goggle on.
Oh, I'm
it
sorry.
becomes
Yes. Yeah. I'm
non-fungible.
sorry. I switched them up. Yeah. Bitcoin is fungible. If you put the goggles on, they're non-fungible. Exactly.
Well, if you're a Monero guy, they say they put the fungible. All Bitcoin can be.
And there's an exchange where you can sell these,
Well,
just like you
Bitcoin
can
can be
do like
blacklisted. It
Dogecoin.
can't
Uh-huh.
be a particular
Right.
asset.
Yeah. Yeah. You could blacklist
But
UTXOs, and
using-
maybe that has the same
but
concept.
Bitcoin doesn't
So.
know anything about it.
Yeah,
Any
but
other
Bitcoin by itself is like,
ends up just
for the most part,
being
still
more
fungible,
like-
right? Yeah, the sat tracking is makes it, gives it a non-fungible.
Yeah, no,
Yeah.
there's some rare sats.
Create a
and
token or
sats.
a
Yeah.
NFT or-
And I see Prem messaging, but we're about to end the stream soon anyway.
So
Yeah,
you
I'll
got-
probably end it.
What's the difference between an ordinal and a rune?
I'll just end the stream first. I think this is all I had on fees and coin selection. So, thanks for watching, Prem and whoever else is on the stream. So, yeah, thanks everyone.
Well, I meant to do a hard reset unfollow.